Hello, Math 7 students. This is Open Up Resources Unit 4 Lesson 6. This is part 2. We ended up not finishing the lesson in our last video, so part 2. We're just going to pick up where we left off. We are going to look at these same types of percent problems, percent increasing and percent decreasing. We're going to look at what they call tape diagrams. So we can see down here, it's showing what 100% would look like on a bar diagram. And then we see something else is happening. We still have that same 100%, but then it's showing 25% that's blue. Beyond that, this part B shows that same 100%, showing what that would look like, but we can see the 100% below it, but then there's a blue 25% that's part of that. So we need to try and figure out what that means. We have these 4 situations here, and you need to match each situation with one of these 2 tape diagrams. Compared with last year's strawberry harvest, this year's strawberry harvest is a 25% increase. Which tape diagram is going to be better to represent A? Problem A, is it going to be Model A or Model B? Sophie. Yeah, exactly. An increase of 25% shows an extra blue 25%. Nicely done. So this is going to be Model A. B, this year's blueberry harvest is 75% of last year's. What does that mean? If it's 75% of last year's? Joshua. Okay, if it's 75% of what it was last year, it doesn't say it in the problem, but we interpret that to mean it must have decreased 25% because the original amount decreasing by 25% is how I'm going to get to that 75%. And even though this part isn't labeled as 75%, you interpreted that correctly. 100% subtracting that 25%, this is going to leave us with 75% of that. Nicely done. Okay, C, compared with last year, this year's peach harvest decreased 25%. Compared with last year, this year's peach harvest decreased 25%. What model is that one going to be? Luke. How do you know? Yep, this has an increase of 25%. This shows that decrease. So compared with last year, this year's peach harvest decreased 25%. That's why that 25%, here it was extra, here it's kind of backed out. It's taken away from that. So yes, this is Model B. Next problem. This year's plum harvest is 125% of last year's plum harvest. Which model is that going to be? Trace. Good, 125% of last year. So if you take a look, here's that 100%, but with the extra 25%, what does that make this? That's 125% altogether. So 100% plus that 25% is how I get to that 125% that it's talking about in the problem. Oops, that erased. Okay, I think that these models demonstrate that there are 2 ways that we can think about these problems, just as we demonstrated with the 2 different ways that we solved these problems yesterday. If we compare B and C, one way that I can look at these problems is decreasing by 25% and then figuring out what that decrease is. Another way is knowing that 100% decreased by 25% is going to be 75% and just calculating with that 75%. That's illustrated very nicely with these problems and with these models. So now your turn, draw a diagram similar to the ones that you see above. Draw a diagram to represent these 2 situations. The number of ducks living in the pond increased by 40%. Draw another diagram for the number of mosquitoes decreased by 80%. I would love for the number of mosquitoes to decrease by 80%. That is a win for humanity, I tell you what. Okay, we're gonna pause the recording and I want you guys to work on those diagrams. We'll come back together in just a few. Okay, we're gonna go over it together. I have a student up at the board ready to draw their diagram. Go ahead, Dylan. All right, he drew a bar. Looks like that's going to be that 100%. 40%. Okay, good. The only adjustment that I'm going to make is this. I want to see that same 100%, so I'm just going to draw a line saying, oh, there's that 100%, and this from here on out is that extra 40%. Nicely done. So the number of ducks living in the pond, how does it compare to last year? I don't want to say increase by 40%. How does the new exact amount, how does that compare to last year's amount? We could use that with one single number. What would we say? We'll come back to it then. If you can't figure it out now, we'll come back to it. Another volunteer to go up and draw B. Carter, go ahead. All right, so we know what our 100% bar looks like. Draw on the same size bar. Okay. That's X'd out. The amount that is X'd out, what does that X'd out amount represent? Dead mosquitoes. Mosquitoes that didn't hatch. This is the 80% that's mentioned in the problem. And that, the way that he wrote that, that helps answer my next question. Let's come back to the question I asked here. The new amount of ducks, how does it compare to the last year's amount of ducks? I don't have a number, so how does it compare? What's a number I could use? Luke? Not 140, but 140%. Yeah, 140%, exactly. So the new amount of ducks is 140% of the original or last year's number of ducks. If we have a 40% increase, that's 140% of last year's. And this diagram also has it labeled for us. 80% of it is gone, that's why it's X'd out, and I'm left with just 20%. So there are now, what is the number I would use? 20%. 100% minus that 80% is 20% of last year's. Okay, great job. Are you ready for more? What would it mean to say there is a 100% decrease in quantity? What if that problem, instead of an 80% decrease, what if it's a 100% decrease in mosquitoes? What if it's a 100% decrease in ducks living in the pond? Draw a model and then discuss, and we'll come back together. We're going to pause the recording as students discuss. Okay, we're ready to talk about it on the recording. I have another student but the board. Joshua's going to draw a model to show how he answered this question. Okay, I think that model makes it very visual and I have no questions. Let's just talk about it. This bar is representing that same original 100% that we saw in the other problems. And if it's a 100% decrease, let's look at what should be there and isn't there, right? All of this was part of that original 100%, but it's no longer there. All that amount has been X'd out, as we saw in that last problem. That's gone. So what is it that I have left, Joshua? 0%. Yep. So 100% decrease in quantity means we have nothing. Okay. Can you give an example where that might make sense? Does it make sense for it to be ducks in a pond? Probably not. Probably not. What kind of a situation would make sense? Yes, Liv. Say that again? Bread in a kitchen because it was eaten. Right? We have 100% less bread today than we did yesterday because we ate it all. Gideon. Yes, wouldn't that be fantastic? 100% decrease in COVID cases. That would be fantastic in the future. Yes, Grant. 100% decrease of cookies in the break room. I love it. That sounds like a line from a sitcom. A sitcom about a math classroom that's super nerdy, and we use percents in our punchlines, right? Love it. Love it, Grant. Okay, let's go on. Agree or disagree. Do you do you agree or disagree with each statement? And then you'll explain your reasoning. Employee A gets a pay raise of 50%. Employee B gets a pay raise of 45%. So, employee A gets the bigger pay raise. Discuss with your groups. We'll move on to 2 in a second. Discuss just number 1 with your groups right now. Then we'll come back and talk together. Do you agree or disagree with this? Let's pause the recording. All right. What do you think? Do you agree or do you disagree? Let's take a quick vote. Is there anybody who agrees? Okay. Most of you. Is there anybody who disagrees? Nobody. Okay. Talk me through it then. Grant. Okay. 50% is greater than 45%. So, of course, it's going to be a bigger pay raise. Unless it's not. Luke?
There's some other factors that could come into play, like how much the employee actually makes.
Yeah.
Because if employee A makes like $10 an hour, he's getting now $15 an hour. But if employee B gets a pay raise and he does like $30 an hour, he's gonna be way up there and A's gonna be way down.
Yeah, you're exactly right. A percent maybe isn't quite enough information. If employee A is the bagger at the grocery store and starts at $10 an hour, and employee B is the company CEO and is making $30 an hour, his $10 an hour increase, employee A's $10, or not $10, 50% increase. So let's see, that's going to be 100%. Plus the 50% increase is 150% of $10. We can type that into our calculator. That would be 1.5 times 10. And just as Luke said, that means employee A is now making $15 an hour. Employee A is really happy, right? That's a big pay raise for him. But is he making more? Is he having a bigger raise than this one? Okay, let's do those calculations. Grant, I see your hand. Let's finish up these calculations and I'll touch base with you, okay? So $30 for the CEO getting a 45% pay raise, so 100% plus that 45% is equal to 145% of the $30. What I'm typing into my calculator is that 1.45 times 30, and what is the CEO's new pay rate? I haven't done the calculation. What's 1.45 times 30? Luke thinks 43.5. Yep. So how big was the pay raise for employee A? How much was the raise? That's $5, yeah. And what was the raise here for employee B? That was a $13.50 raise. Okay. Grant, what are your thoughts or your comments that you were going to share with us? Well, but percents are relative to where we started. So although employee A is getting a bigger percentage of his pay rate that's being increased, when you actually compare the dollar amount that they're each getting, the dollar amounts show that we can't just rely on just that percentage alone. That just that percentage alone isn't quite enough data. Okay, so I hope Luke has all convinced you all that maybe we should disagree with this. Okay, the percent isn't enough information alone. When we're dealing with percents rely on a comparison, usually to the original amount. So the original amount has a big impact in this. Even though employee A got a 50% raise, his raise was only $5. Employee B got a 45% raise, his or her raise was $30. There it is, $13.50. Okay, with that in mind, let's answer this next question. Shirts are on sale for 20% off. You buy 2 of them. As you pay, the cashier says 20% off each shirt means 40% off the total price. Do you agree or disagree? Discuss with your tables. Okay. Let's take another quick vote. Raise your hand if you agree. 2, 1-ish. He's doing a sideways sort of, maybe, yes. Raise your hand if you disagree. Okay, the majority say disagree. I want to hear from the agree first. Or in your saying kind of, sort of. Tell me. That makes sense, right? So we're doubling the price, but we're also doubling the amount that we get off because we're buying 2 of them. Okay, I'm convinced. What would you have to say about that, Gideon? Okay, good thought. I like how you tied it back into a previous lesson with our marbles. So 20% off of one thing. Let's just do this problem. Let's say we have a shirt. Let's say that shirt 1 costs $20. And let's say that shirt 2, should we just make them the same price or should we be creative and make it something different? Okay. 2 shirts at the same price. Okay. So if I get 20% off of this one, right, that's going to be our 20%, 0.2 times the $20. What is the discount going to be here? 20 times 0.2. I got $4 off. Okay, so $4 discount off of that first shirt. I've already done the calculation, so is it okay if I just take that 20% off of the second shirt means I get another $4 discount on the second one. So $4 and $4 means I have a total of an $8 discount. Let's compare it to the original price, right? $8, the original price is $20. Convert that to a percent. $8 out of $20. What is the percent here? I'm going to write a percent proportion. 20 changing to 100. 8. Huh, I got 40 because I'm multiplying by 5, so it turns out Oren's right. Yes, Joshua? Mm-hmm. Good job, yes. Exactly. Nice job catching that. So it would kind of make sense if we looked at it this way, that yeah, we're getting $8 off, but we're getting $8 off out of not just $20 total. What was the original price of both of those shirts? $40. Do you see that, Oren? Now let's compare it to that $40 then. Write that as a percent. $40. 8 out of $40 is equal to 20%. Sure, I'm not going to go that way. We're just going to go, that's equal to 20%. If we're combining our offers, it still is just a 20% off of the total amount because we're not just combining the discount, we're also combining the grand total as well. Okay, great interpretation. You guys figured it out. Let's summarize. Imagine that it takes Andre 3/4 more time than it takes Jada to go to school. The first thing I'm going to do is understand that 3/4, because it's using a fraction, even though we didn't use fractions anywhere in this whole lesson, 3/4 is what as a decimal? Numeracy here. 3/4 is what as a decimal, Bella? Yeah, 0.75. So I wouldn't normally say Andre takes 3/4 more than the time it takes Jada. We could. we probably wouldn't even say it takes her 0.75 times more. We would probably say it takes 75% more time. Therefore, we then know that Andre's time is 1 3/4 or 1.75, or even better, 175% of the time that Jada takes. Here's Jada's time. Andre takes the same amount of time plus an extra 75% more. So 175%. That model, I think, really clarifies that. We say that Andre's time is 75% more than Jada's. So we can say it's increasing or it's more than. But we can also see that Andre's time is 175% of Jada's time. So we can talk about it in those two ways. We can say 75% increase, or we can just compare the new total amount, 175% of the original, of Jada's time. In general, the terms percent increase and percent decrease describe an increase or decrease in a quantity as a percentage of the starting amount. What that really means is we're comparing it back to the original. For example, and we saw this with some cereal, if there are 500 grams of cereal in the original package, then 20% more means that we get 20% more of those grams as well. So 20% of 500, we can do it in those two steps. Find the 20% of 500 first, and then add it together. That's going to be 600, or I have to do those calculations both using a calculator. But if I think about it as 20% more, that's 100%. Plus 20%, that's something I can do in my head, and I don't need a calculator for that. I know that that's 120%. Then I can just go straight to 120%, or 1.2, times that 500, only typing in one calculation into my calculator instead of two. There's that model to represent that. 100% plus the 20% is 120%. And the majority of students in this particular class are already thinking that way, so it's not going to be a stretch for the next lesson. Let's finish up with our cool down. The number of fish in a lake decreased by 25% between between last year and this year. Last year there were 60 fish in the lake. What is the population this year? Draw a diagram. If you get stuck, complete this any way that you want, working with your groups. I'm going to pause the recording. We'll come back together in 30 to 60 seconds. Ready, set, go. Okay. I know that if it's decreasing by 25%, I know that that's 100% decreased by 25% is going to leave me with 75% of the amount that we had last year. So notice what I did. I did that calculation in my head, 75%. Now I'm going to use that new percentage to calculate how many fish there are. So 75% of the original amount, and that original amount of fish was 60. I can't calculate with percents. The calculator doesn't do that. So I have to change that percent into a decimal. 0.75 of means to multiply, and the original amount is 60. When I type that into my calculator, I get 45 fish. How'd you guys do? Thumbs up, thumbs sideways, thumbs down? Fantastic. Your homework is the lesson 6 practice problems. That's it for today. Thanks for watching, and we'll see you next time.